Starting at the years 2000 to 2003, epidemics have been breaking out in hospitals around the world. Common symptoms include diarrhea, fever, nausea, and abdominal pain. In 2011 alone, the disease responsible had resulted in 29,000 deaths. Scientists have determined the source of these epidemics to be the bacteria known as Clostridium difficile. However, until recently, we weren't sure about what caused C. difficile to start breaking out. Now, though, we have good evidence that dietary trehalose, which is simply just a sugar consisting of two molecules of glucose, has increased the disease's severity. This likely happened because in 2000, the FDA in the United States approved for food manufacturers to use trehalose in food. This caused the trehalose concentrations rising from 2% in food to 11.25% in food, and this corresponds to the emergence of the two important strains of C. difficile and the outbreaks they've caused. The first strain of C. difficile is called ribotype 027 or RT027, and the second is called RT078. I'll be calling these 027 and 078, just time's sake. But scientists analyzed the carbon sources of both of these strains and found that trehalose was a significant contributor to the increased growth of 027, the first strain, where further experiments showed that only 027 and 078 compared to all the other strains of C. difficile out there showed enhanced growth on trehalose concentrations of 10 millimolar, while other strains showed zero growth. In other words, these two types of C. difficile can grow under extremely low trehalose concentrations, while other types simply can't. These two particular strains of bacteria are a direct result of evolution, which is a process where a population, and in this case it's the C. difficile bacteria, experiences a change in the allele frequency of a certain trait or gene, where in this case it's the ability to metabolize trehalose at very low concentrations. This makes sense because as the trehalose concentrations go up in food, the bacteria that can metabolize it at a lower rate, at a lower concentration rather, can survive better than the ones that are simply just surviving on glucose. As shown in this graph, showing absorbance with the different types of sugars, glucose, all three can do well with glucose, but with the trehalose, all the other strands can't really grow or don't have a better absorbance and don't have as much growth obviously than the 027 or the 078. So in the case of the C. difficile, scientists then wanted to find out what was happening on a molecular level that was causing this enhanced trehalose metabolism. Both types of C. difficile have a gene called TreA that encodes for an enzyme that breaks down trehalose. And both types have a transcriptional repressor that regulates this amount of enzyme. In 027, this repressor has a single point mutation that arose from a nonsense or missense mutation. It allows 027 to activate TreA expression at concentrations of trehalose 500 times lower than other strains. Scientists then wanted to know if trehalose metabolism was causing increased disease severity, and if it was, how? In further experiments, scientists injected mice with either normal 027 or 027 TreA deletion mutants, so TreA would no longer be functional in those mutants. And each of the mice free-fed on 5 micromolars of trehalose. It was found that the mice injected with 027 that had the nullified TreA survived much higher than normal 027, indicating that trehalose metabolism contributes to disease severity. This is because normal 027 produces a toxin called toxin B that contributes to increased virulence. Similar experiments were done in the 078 strain, where they found a particular gene which encoded for a trehalose-specific sugar uptake method, PTST for short. Scientists, when they took away the PTST from certain populations, they found that they couldn't grow in the small concentrations of trehalose. But when they gave the PTST to completely different strains of bacteria, they could grow in the low trehalose concentrations. This concluded that the PTST is necessary for growth on low trehalose concentrations, showing that PTST confers a fitness advantage on bacteria that have it. So to sum it all up, scientists determined that the two epidemic strains of C. difficile, 078 and 027, both have efficient trehalose metabolism at low trehalose concentration, and both require this trehalose metabolism to have increased virulence and increased fitness. The timeline of increased trehalose usage in foods matches up with the origin of the 078 and the 027, along with the epidemics that both have caused. We do appreciate your time listening to us today, and we hope we maybe expanded your knowledge on what's going on in the frontier of research today. Thank you so much, and have a wonderful day.